Alright, what's up guys? So we're back and we figured out the source of the clickable card highlight bug. We determined that the collided cards dictionary has errant values due to minor variations in the Y values of the cards in the hand. So let's go ahead and get rid of this because we know that's Alright, so we actually have to deal with this from a perspective that's not going to mess up other code, because we do rely on the Y values to organize this dictionary. Honestly though, so I'm trying to imagine like the scenario where let's say there's minor variation throughout the Y values throughout the entire game. Now we have two possibilities here as far as addressing the problem. The first is that we fix the of the minor variation. That, I mean, that actually shouldn't even be an issue, like at all. I'm not. Oh, I know what it is. I know what it is. It's because whenever we're moving cards, the cards move like diagonally. They are moved in a way that uses, dynamic math. It just uses it uses a ratio like of the angle of the card and everything to make sure that the line that the card travels is straight and not curved. And all that's coded in the card movement function. Now, I'm pretty sure I'm not positive on this, but I'm pretty sure what's happening here is as the cards are moving, we have it set to where once the card gets a couple pixels away from its destination, its intended destination, we kill the card movement. So like it doesn't have to be perfectly on the spot. As long as it's within a couple pixels distance, we basically say that's good enough. At least I'm pretty sure that's what's going on. And that would make sense to account for this minor variation. So we could probably fix that because you can actually see visually, and you might say, oh well, that's realistic, it's a little bit off. Who cares? I just care about the code working properly. And as far as I'm concerned, I'm pretty sure this it it not landing in the proper location, like perfectly, relative to the Y, is is not good. Like it's just, it could cause bugs other places, because this same snippet of code for clicking cards is used throughout the entire game. So like the entire game, they're going to be clicking cards, and there's certain instances where they're clicking multiple cards in a meld. There's instances where they're clicking, I don't know, maybe they're clicking two different melds, and I don't want it to confuse. You know what I mean? I don't want it to confuse anything. So I would like for this to be perfect. And secondly, on a like another note, I don't want us to run this code during this section. I don't want us to check the Y distance at all. I would rather that we would only use this section whenever we're actually dealing with vertically stacked cards, because this is not vertically, this is horizontally. There is no reason for us to look at the Y value in this instance. So we actually have two problems, and I think I want to fix both of them. So the first one would be we can actually we'll put this in pressing issues, and we'll call it, what are we gonna say that this is? We'll call it variation in pixel data. I guess that's good enough. And discovered source of clickable card highlight bug, wherein .y vals are slightly varying. Quite certain this is due to card movement logic, which causes cards to be close enough when compared to their intended destination. And then if this is the case, need to make it so that in these instances the card is finally given the intended destination exact x, y vals, i.e., well, I know it, I don't even have to elaborate on that. Okay, and then the second one is word logic. And this is gonna say need to fix logic associated with lines number 984 to 987. 987 in game pi, which uses y to determine what's called collided cards dict. We should only use this logic when we have vertically stacked cards, not therefore modify logic to a new if else a solution for this would be only that logic if we had, instead of like adding in some special arg or some that we have to trigger, and in these instances I think an easy route to check for this, check for variation in the y values of the clickable card list. The issue here is we have a lot of cards in the clickable card list, but we have not a lot of variation in the values. There's some, not enough of a difference to be considered vertical stacking. So like regardless of the fact that if we fixed the variation in pixel data, this will disappear, we still don't want to enter into this logic branch if it's useless and it's just basically dead code in those horizontal stack scenarios. So we just don't want to use it. Like we don't need it. We don't want it. We want it to go away. So we could only enter into that logic if there was at least a, we'll call it a card top pixel difference. Gotta figure out a variable name for it. We could figure out a card top pixel difference minimum variation, and this would designate we're dealing with vertical stacking. So basically we would just add in if card top picks not or less than card then we would don't execute that logic. And first we would actually check say for current card in self dot click card list. Yeah, then current card in clickable card list, we would card we could just say card top, so card top val card let me say card Y. What is like top? How does that get determined? So we have the see, so we measure the top but cards, the rects actually have a top. So that's a separate thing. Like that's a pie game. Yeah, that's a pie game thing. Construct. That's not something that like I created myself. That's something that exists through pie game. Alright, so yeah, we would have the card top val, which would basically just equal the card dot rect dot top. And we don't even need to do that. We could just say, we could call it the card top dict, and then we would assign the, or we could just have a list. We don't necessarily have to have a dictionary. We could have a card top list. Yeah, we could have card top list, and then well, but then we would basically just be checking the, then we would be checking the like logic. We would just be checking different logic, which would take like the same amount of time, right? But if the other logic like causes bugs, it doesn't really matter if it takes as much time. It's not about computational power. It's about executing proper code. So yeah, if we, I feel like there's an easier way to do this. Yeah, all we do is iterate through the clickable card list, and we would just append to the card top list the card rect top, and that would give us a list of the tops of the cards, which is the Y value of the top of the card, of each card. And then we would check to see if there's variation between them. So we would then say trying to think of a clever way to do this. Well, you know, so we could just get the minimum and then the maximum, or in a perfect world, we could just see if they're all equal to each other. If they're all equal to each other, that would be a lot easier. I don't know. I don't know how much easier per se that would be than, like, would that be? Yeah, if we just said if they're all equal to each other, that would require comparing them all against each other. And I think that would actually probably be more computational work than if we just did, we would get the min card top would equal the minimum of card top list, and then we would have the opposite of that, which would be the max card top, which would be the maximum of the card top list, and then we would do max card top minus min card top, and that would give us the difference in the card tops. Now we would call this the card top diff, and we'd actually call it difference, because diff refers to like a difference in code. Or a diff could also refer to a set. Isn't that what they? Yeah. A related Python sets. A diff can refer to finding the difference between two sets. Between two sets, yeah. So we don't want to call it that. We would call it difference, because that would be myth namespace, and we don't want to do that. So we would get the card top difference, which is the max card top minus the min card top, and from there we would want to check if card top difference is greater than or equal to actual card to card top difference, or we'll call it vertical stack card top difference. Yeah, vertical stack card top difference. And we'll just say the actual difference pixel value between 2x cards stacked vertically. I'll put vertical. So the card top difference is greater than or equal to the vertical stack card top difference, then in this case, what do we want to do? Well, in this case, we would that means we're dealing with this. Yeah, that means we're dealing with vertical stacked cards. If the card top difference is greater than or equal to the vertical stack card top difference, then that means we're not dealing with a couple pixel variation here. We're dealing with actually vertically stacked cards. So in this case, then we would want to in this case run collided cards dict code, and we would have else. In this case, we would not run the collided cards dict code. We would simply grab we would instead, well, really we would check for the X val, right? Check for X instead. That would be the proper way to do it. Yeah. Because currently, we really just get lucky because of the way dictionaries work. We get lucky. But in all honesty, that's not what should happen. So we don't want to get lucky. We want to have proper code. So we have check for X instead. So how would we do that? Basically, the same thing. We would use the collided cards dict. We would actually look for the X. So currently, let's go to game and see how this works currently. Currently, we would register each key value entry to the collided cards dict based only on that position Y dist to the card top. But we want to modify that to use to register our collided cards dict would just be different, and I think that would work in what we're trying to do. So we would end up having the self-collided cards dict at the we could use the left card rect dot left, which is the left side of the card, because there's the left edge of the card is always, so the left edge of the card is visible, and we would compare the collide point, card rect collide point, so we would, yeah, in that case we would basically run this but modified. In this case, we would be dealing with vertical stack, say horizontal stack, and then this one is vertical stack. So in this case, we check for the X instead. We paste in this code. So we have 4 card in clickable card list. We would then check to see if we collided with the card. Okay, then we would say that we did click a card, and in that case we would say card position Y dist to card top. No, that's not what we want. This would instead be position Y distance. We could change that to say something a little more accurate, like X dist to card left would be the event position 0 for X minus the card rect dot left. So then we have self-collided cards dict at so then creating a key value pair to the collided cards dict would have the card X dist to card left as the key and the card as the value. And then in that case we would have iterated through the clickable card list. We would have checked to see if it collided with our click point. If it did, then we would change clicked a card to true. We would then set the card's X dist to card left, which we actually don't need that to be an attribute. We could just have this be a variable. Because like, does position Y dist to card top need to be an attribute? Just be a variable like this. X dist to card left. That's the only thing we need to do. Iterate through the list. We check to see if it would collide point. Then and I guess first we would want to assign the points. So I'll put assign, instead of executing this function multiple times, instead assign the collide point first. And way at the top. And then we'll start our new line. There we go. Okay. Work. So the first thing we would do would be to assign our collide point, and that would be equal to the event. Well, no, we already have the event position. I'm tripping. Okay, yeah, that card rect collide point is a method, and that's fine to use. We're good using that. So check for X instead. I gotta use a restroom. I'll be back. So else we would horizontal stack, check for X instead. For card in self-clickable card list, if card rect collide point matches the falls, or if the event position falls within the collide point of the card, we would change clicked card to true. Xdist to card left would equal event position X minus card rect left. Okay, then couldn't we just like do we have to yeah, we wouldn't do it like this. We don't need that. That would just be something for Y distance to card top. We would just really need whichever value is the lowest. Well, we would basically need a list that contained all the card X values, and we would compare it with all of the collide point for the event position 0. So this is not going to be but instead create we could have a list that contains all the X values. Yeah, we still would need the list. So we would create the list beforehand. It would be called the clickable card list X vals list. It would be an empty list, and then we would iterate through the clickable card list and see if that event position fell within the card's collide point. In that case, we would then do the card to that list. So we would clickable card list X vals list append that card X. Yeah, because we would then have a list of all the collided cards' X values, right? or we could actually call this the collided cards list. Collided card list. So the collided card X vals list, because that's a more accurate description, I think. Yeah, we would append to the collided cards X vals list that card's X value, and that would replace this line, the self collided cards dict at X dist to card left. So now at this point, after we're done iterating, we have a list of the collided cards X vals. So then first we would need the, what was it called? The event position. I deleted it. I should have left it. Where was it? There it is. Event dot pos 0. This, then we have the, say, collide X position equals, and we can actually just leave that as is. We don't even need to assign that to a variable. So we would just say and we would iterate through the for card in collided card val list would then the event position at index 0 would be the X value of the event where we clicked. We want to check if, and this is actually for X val, we'll say X val, if X val is because we're going to be starting from the left to the right, I would think. Yeah, that makes sense. So we would start with a lower X val. So once we got to the point I feel like I need paint for this. So we would have these cards like so. We have just a few of them. Okay. So let's get rid of this. They have a few. Well, we do need the edge of them, I forgot, so it would be like this. have 1, 2, 3, 4, and 5. Now, xval lift which we'll just call xvl, is going to consist of, let's say this one is 10, and then this one is 20, 30, so on and so forth. And then 40 and 50. Alright? And then our event position is going to be this red click. Bam. So that's going to be our event position. And we'll call this the E for position at 0 index. Add 0 equals, and this is going to be like 28. 28. Okay. So our XVL would consist of 10, 30, 50. And then we are trying to figure out, we're going to be iterating through the XVL. So since we're going left to right, we're going to start off here, and then we're going to go to, we're going to go right. So first check 10, and then 20, 30. So once we get to an XVL that's greater, once we got to 30, we would want to stop iteration, because we know that we reached. So we'll put stop iteration. Yes, alright. The reason we want to stop iteration is because we know we've reached the next card's left edge after that we clicked. Wouldn't that mean we could deduce the card that we clicked based off of this card's left edge, which will right here? So this, that's where we would stop, and then we would say, okay, since 10 less than our EP0 and 20 was less than our EP0, we keep going, but then once we get to the 30, we would stop, because we know we have surpassed the EPO. We would then go back to the next one. Yeah, we would then go back from 30 to 20, and say, hey, if this one was greater, then we know the card that we clicked is actually associated with this 20 val, which would be that card, this card. Oh, we'll just leave it as a straight line, or we don't even have to do that, but that lets us know we are dealing with the card that we clicked. I mean, I think that makes sense to me. So then the card, oh well, wouldn't we have to have a dictionary? Yeah, we do actually need a dictionary. We need a collided cards dict, because we don't just need the value, we actually need the actual card. So this would instead have to be a dictionary, but otherwise the logic checks out, I believe. Yeah, that makes sense. So we would use the collided card dict, which is the self-collided card dict, right? Cards dict. But that would already exist. So then we would just do collided cards dict. So use append. We would use at card X. Well, hold up, let me think about this for a second. Okay. How did we do this before? Card rect collide point. Okay, yeah. We just say if card rect collide point, the event position falls within the collide point. So yeah, for card and self-clickable card list, if card rect collide point at event position, we would then use the card X no, we'd use the card left, right? Yeah, we'd use the cards left to register it at in the collided cards dict would equal that card. Okay. Yeah, and that would give us, in this case, the collided cards dict would consist of, if we clicked right here, it would consist of, well, it would actually only consist of 1 and 2. It would only consist of, because it wouldn't actually touch the third card. It would actually only consist of these 2 cards. It would only consist of cards to the left of it. So this is bad, actually. I have to redo this. Yeah, this is not right. Let's redo this. We can keep that, and we'll keep here, we'll say our point was right here. Now our event position 0, our EP 0 would be, let's just say 28. Alright. Or, no, that's not right. This would be 18. Okay. 18. Because this is our X. Our X values would equal, let's just say this one would be 10. And, well, if we start at 0, let's do it like that. This is 0. This one would be 10. And then this one would be 20. Okay. So we don't need to worry about the rest of them, because what's going to happen is whenever we click this spot, it's going to give us our event position 0, which is 18. It's then going to iterate through our clickable card list. So our clickable card list would be our CEL is going to consist of three, 4, and 5. Okay. But let's redo that. That looks really bad. 3, 4, and 5. Okay. It still looks terrible. Who cares? Anyway, this is a list, so it's gonna be closed in with brackets. All right. Then it's going to iterate through this clickable card list, and it's going to start here, and it's going to check to see the card dot left, and the card left would be 0 for 1, 10 for, and 20 for 3. So it's going to iterate through the clickable card list starting at 1, and it would check to see if 0 is less than 18, and that checks out, so that's true. Then it's going to check to see 0 is less than 18, and then we're going to check to see if 10 is also less than 18, which it is. Long story short, we know this one is going to be less than 18, so we'll just put less than 18 like this. If it's less than 18, it's good. So this one's going to check out. So this one's going to be included in our collided cards dict. So we'll call this the CCD for the collided cards dictionary. Well, I'm sorry. That's not right. It would be called the... Well, we don't actually even need to do that per se. We don't even need a list. We would just iterate through the collided cards dictionary, and yeah, we would iterate through the collided cards dictionary at the associated key. The key would actually be 0, 10, and 20. So we would just iterate through the keys and see if this X value is less than the collide point, which would be, and card it would check out, and then the card it would check out, but for the third, not check out. Stop here. All of these cards are not even going to be included in the possible options. We would stop iteration as soon as we hit that 20. So the only possible cards would be 1 and 2. So then once we hit this 20, which would be associated with card 3, we would just go back one element. So we could just keep track of the previous key. Each time as we iterate through, we would assign the previous key. We could just convert that collided cards dictionary to a list, and I think that would be easier, because then we would just be dealing with the list. We can deal with the dictionary afterward, but we would iterate through the list, which would actually consist of 0, 10, and 20. So I wrote that wrong. I'm not going to redo it though. Once we hit 30, card 3 right here, stop iteration, and then we would go back one index. Be very easy to do. All we would have to do is have an index num tracker, an integer that gets incremented each iteration. We could use the index to grab it, and we would just grab the previous card. So once we hit a value that was greater than 18, we know that the card before that is the card we clicked. Yeah. Done. Smiley face. That works. Some kinks in that, but I got it figured out. So how do we write this out exactly? We have the else card list, card rect collide point, the event position, click to card. True, we add the collided cards dict key at cards. First one would be 0, and then the second one again left side. So the first one would be this one, 0. Left, which would be the 10, and then the, well, that's the only 2. Oh, doesn't work again. I messed up again because the collided list actually only consists of there. It would actually only consist of 0 and 10. It would include 20 because 20 is actually oh no, it's even easier than that. It would be the last card that gets added to collided card dict, right? Because if we, would that always work though? Like in this situation, if we iterated through the clickable card list and then appended each one that fell within the collide point of a card, that list would only consist of 0 and 10. It would only consist of these first 2 cards. It wouldn't consist of 5. So in that case, we could just use that all by itself and say next card didn't get, it's gotta be the last card that was added. The next one further, greater, or it wasn't even in the collide point. And as we move right, as we iterate through the list, we're going to be going in proper order because we have the counter system, which ensures that we're going in order, right? So we would just use the last card that was cards dict. So last card in collided cards dict. But would that always work? That's the question. I don't know if that would always work. That we have to check. So what if we had a different set of clicked cards like this, or a different collide point, not collide point, a different, what you call it, event position where we click the screen. So we have this rectangle, which is all the cards in the hand, and then we have these cards here. Right. And then, so we have 1, 2, 3, 4, 5, and 6. So this is a new scenario. And in this one, let's say we click right here. Boom. So if we click right there, that would actually include, as far as the collide point, so our collide point would be different here. Let's get rid of this. We have so we have our collide point list, our event 0, and then our other thing. So firstly, our event X, where we clicked, let's say if the X is equal to 0 right here, and then 10, then 20, then 30, 40, and then 50. Alright. It's really ugly, but it's all good. The comma's kind of backwards. Alright. So if those are our X points associated with each card's left, in that case, our collided card list would consist of, and let's actually make this green, because green matches up better with, we can't use the same color as blue, we have to have a different color. So our collided cards list in this case would be completely different. It would consist of, let's say our clicked point here is going to be, let's change it, let's move it right here. So it's bam, right inside of the 5. That would be, let's just say, what is between 40 and 50, because this is 0, 10, 20, 30, 40. So we're at 45, yeah, so this is 45. Alright. It's our card list that consists of any card that exists within you know, the card's rectangles. So 6 is out. 6 does not get included because 6 is too far to the right. The event position does not fall within this collide point in here, but it does fall within the collide point of this card for sure, obviously, and then it's gonna fall within 4 as well, because 4, the actual width of this card is gonna go like all the way over here. You see what I'm saying? The card is a lot wider than what you see. The back of the rest of the card is hidden behind the 5th card. So it would also include 4, and it might even include 3. It might even include 3. Yeah, I think in this case, well, yeah, in the game it goes like 3 cards over, 3 or 4. Include all 3 of these. it would include 3, 4, and 5. The way we drew it, it really wouldn't include anything else, but so the collided card list would consist of we would have the dictionary. The dictionary would be the collided card dictionary. The collided card dictionary. That would consist of and also, just for note, it wouldn't include the 2 because the 2 is too far to the left. The event position is not within cards collide point spectrum, like, you know, it doesn't fall within that area. Same thing for 1, obviously. So the CCD consists of key. The key is actually the X value. So the key would be, for 3 would be 20. Say 20 is the key. 3 is the card. Then we would have so we're going off of the left, remember? It goes off of the card's left. The card left becomes the key. So we would have 20 for the first one, 30 for the second one, 30, and that would be have a value of the card, which we call 4. And then we have again the 5th card, which its left would be 40, and that is the card associated with 5. Yeah, I know that's ugly, whatever, it's fine. So the collided card list is going to consist of only the keys, actual X values of the left side of the card. So that's going to consist of 20, 30, and I forgot to draw this little purple line right there. And then we have 30, blah blah, and then the last one is, so we have these 3 values. Alright, from there, iterate through the collided cards list, because we have all the cards that it collided with. Now we're going to start and we're going to check to see if it's less than, so we'll call possible cards, or like, well, we're not going to worry about that right now. We'll just keep going with this thought experiment. We'll say less than 45, because we're checking for the left side of these cards to see when we're going to get, we're going to say left. Is going to be less than, it's going to be less than, so all 3. So that means our clicked card, finally, we would call the clicked card use associated with the left value, the collided cards, and that's 5, which would be this one right here. That would be registered as our clicked card, and that's using the same logic. That's using the logic that the last card in the collided card list, we could call it the collided card left list, it doesn't matter, is gonna be the click card. And that would work in the scenario that we in this scenario. Now, what if we clicked the last spot? If we clicked here, if we clicked the 6, well, then it would just include, it would have included the well, we would have 50 here, and the dictionary would have included 50 as well, because it would have been in the collided cards, and then we would have got the X value of the cards left, which is 50, and we would have iterated through the CCL, which would have included that 50, and in that case our in 52, since 50 is less than 52, and the last one in our it would have been the last one that we iterated through. Yeah, so basically that would end up being our click card. That would work either way. It would work, I think, in every single instance that I could imagine. We checked if it fell here in the 2, we checked if it fell here in the 5, and we checked if it was the last card. We would basically just check the left side of each card that was the cards dict, and then the last one, since we're always going to be iterating from left to right, would be yeah, I think that's foolproof. I just wanted to make sure, you know, you always triple check before you implement any code, and yeah, I'm like 99% certain that's gonna work. Yeah, so for current card and clickable card list, we have to put this into actual code format. All this is good up to here, and then we would check for the last card in the collided cards dictionary. That simple. Yeah, that's it. Done. Easy. Why does that seem too easy, you know? If something seems too easy, I feel like there's something wrong with it. But I don't know, dude. I'm pretty sure that's right. I don't think there's anything wrong with that code. Yeah, it's got to be right. Last card and collided card sake. So then we just need to reference the last card in that dictionary, which would be, how do you access a dictionary? This is a rookie question, but Python, easiest way to access last item in a dictionary. You can easily access the last item dictionary using the collection's ordered dict. Version 4. However, starting from 3.7, the built-in dict also maintains the order of items. Okay. I actually did forget that. So we would use a list to convert to list. couldn't we just use keys? Yeah, couldn't we just say clicked card equals self collided cards dict dot keys, because doesn't that create a list of the keys? Yeah, there we go. This would get put down here, and this would be put last key. Yeah, last key equals self dot collided cards dict dot keys, and then we'll just say -1 for index to be the last of that, because the collided cards dict keys is a list of the keys, which would in this case be the 0. Actually, we could just do values if we're gonna do a method call. We would just call values, and that would be the click card. Isn't it? It's that simple, right? We'll say dict.values -1 object gets the last object from last value from, right? No, dict values returns a view object. Oh, you can't directly index it with -1 like you would with a list. If you try to do dict, it returns a view object. Oh, see, I'm dumb. I didn't really know that, or I forgot that. So yeah, we would have to do click card equals. So we could do keys, but keys returns a list, right? Or does keys also return? Does keys return a list or view? The keys method returns a view object, meaning that a dynamic view, meaning that reflects changes made to the dictionary. Keys view, print keys view, output. It's a, oh, the key view is dynamic if you modify the data. Hold up, bro, hold up. I gotta test this because I'm like, wait a second. This is not, something is wrong with this. Hold up. Next text segment, there we go. Let's put this to the test. We're gonna say D equals dict, and we're gonna have 1, or we'll just do it. A is 1, and then B is 2. Alright, so now we're gonna say for, or rather print D dot keys. What do we get there? Let's run it and see what we got. Okay, so we have dict keys A, B. So let's print the type of it. So the type of this is gonna be a view object, I'm guessing, based on what, or it says class dict keys. Okay, interesting. All right, so now let's do print D keys at index 0. What do we get then? D keys object is not subscriptable. Gotcha. Okay. Now what about values? It's going to be the same thing. Okay, it's not subscriptable, so if we remove the index and we just print the values, we would get a view object. Obviously it's not subscriptable, so we would have to convert it to a list. So I guess the easiest way to do this would be to convert list of D values to 1 and 2, and then we could grab the final value. Or, you know, we could just do something really clever, and we would just assign current card. But I don't want to do that because that's like, well, we could do it like that. We could keep reassigning the last clicked card, and yeah, we could do that. That's not ghetto at all. That's actually safer. That's like, it's less syntactically complicated. It's a lot more simple. If we just did, as we're iterating through the clickable card list, we would check to see if it collides, and basically the last one would be uh, the the last click card. We just say last collided card, and it would reassign that each time until it didn't meet this if conditional, which means the last one that did meet the condition would get assigned to last collided card. And then once we're done with that iteration, we would simply say that the click card equals the last collided card. Boom. Done. We did it. Okay, that's simple. Took me a really long time to do that, like crazy long. But I'm I'm like I'm 99.9% sure this code is going to be perfect and will fix our issue. Now we have a new system in place for making sure we're registering the proper clicked card um, when we're dealing with two different types of situations: vertical stacking and horizontal stacking. And we have the logic that will make sure in those scenarios we're narrowing down the list to cards that um, the click point fell into their collide points for each card, and then from there it whittles it down based on more logic to that specific card that we clicked. Um, so I just have to review all this again, but I'm actually gonna call it quits. I have an appointment at 4 o'clock, so I have to make it to my appointment. And yeah, so let's do our devlog. And we went from 1119 to 323. There's no way I coded that long. No, I took a break, remember? I was about to say, I was like, wait a second. I didn't actually put the time that we stopped, though. I'm trying to think of... I would say it was an hour and 30 minutes. I remember exactly, actually, the time. It was an hour and basically 30 minutes. So that would have been 12:50. So just say 12:49. All right. And then we did... this one is an hour and 42. Or we'd say an hour and 45. So 326, and then back from that, an hour 45 would be 1, and then 26 and 20, so that would be 140. Is that right? From 140 to 141 to 326 is an hour and 45 minutes. Yeah, that would be 20 and then 25. So it would be, yeah, 141 to 326 would be 2, 3, 25. So an hour and 45 minutes. 2, 3. Yeah, that's right. All right. So that's going to put us at an hour and a half and an hour and 45. That's 3 hours and 15 minutes, right? An hour and a half, an hour 45. That's 3 hours and 15 minutes. So that's 3.25 hours. And from 12:49, we also did continue debugging via playtest. Well, we didn't actually do that. We continued debugging the root cause of clickable card bug, and also the same thing from 141 to 326 or 325, and then we're going to commit our changes, which is going to be our final entry. So this would be 325 to 326. All right, and we finalized pseudocode and first pass actual code to fix bug. And yeah, you just need to put C lines number. Where did we add this code? Things to do. Okay. Stopped here. And this is going to be 10:14, 24. All right. That's line 44 and things to do. 44 and things to do dot text. And now all we have to do is stage, commit, and push our changes. Go down here. We forgot to check our VS Code extensions, so let's just do that real quick. Looks like everything's good. We looked up today because I forgot to do it. And now we can copy all this. So we copied that. Now we're going to kill these game scripts, which I don't know if that would actually cause a bug, but I don't know. Anyway, like could cause issues with committing and stuff. I don't know how that works exactly. Alright, so let's cd back to the root of the project directory, which we did. Now we're going to git branch to make sure we're on the right branch, which we are. We're going to do git add dot to add everything. We could ignore those LF warnings. We're going to do git commit m, double quote, paste in our commit message, which is our devlog entry. We had 10 files changed, 69 insertions, 18 deletions. Now we're going to do git push, Canasta secondary, and that's going to push to our remote repository. And there we go. Now we can exit out of this. We'll go over to our folder, programming, projects, Canasta, copy this one, go to our backup, delete the old one, ignore the message, paste in the new one, and then enter into it and verify it is indeed the correct one. And why wouldn't it be? I don't know if I actually have to do this step. I just like got so used to doing it that I do it anyway. And we verified the devlog was today's date, so we changed the title of the backup folder to today's date to reflect that. And there we go, guys. Alright, so that's it for me. I'm going to go to my appointment, and I don't know, I might do a little bit more when I get back, because it does feel nice to have finally solved one of those bugs that has been around for a while. So fingers crossed, I think our code will fix it, and I'm just going to review it one last time, implement it, and then we'll test it. Maybe we'll do that when I get back.